we're going to be looking at either or probabilities, and these are probabilities where we have a compound probability, two different things going on, and we want one of the two to happen. So when we're looking at these probabilities, there's two different types, the non-overlapping and the overlapping. Now, the non-overlapping are when events cannot occur together, and our formula is right here, the probability of A plus the probability of B. Overlapping events or overlapping probabilities are when the events can occur together, and here is my formula. And it looks kind of complicated, but it's really not. You're adding the two probabilities together just like you did up here, but then you are subtracting off the probability that both of those things occur at the same time. In other words, you're subtracting off the overlap. And we can see this going on here in my examples. The first example that I have is the probability of drawing a 4 or a queen. And you can see in my first circle, I have the probability of drawing a 4. Is 4 out of 52 because there's 4 different 4s. And over here, the probability of drawing a queen, 4 out of 52. And there's no overlap. A card cannot be a 4 and a queen at the same time. So we just add those two probabilities together. When I'm looking at overlapping events, we can see here the probability of drawing a 5 is 4 out of 52 because there's 4 of those cards. And the probability of drawing a spade is 13 out of 52. But notice that I have counted the 5 of spades twice. I have counted it in this circle when I counted it as a 5, and I counted it over here in this oval when I counted it as a spade. So since I've counted it twice, I have to subtract that off once. And so get rid of that overlap. And so you find the two probabilities, add them together, and subtract off the overlap. So we can look at some more examples here. We're going to be identifying each of the following as overlapping or non-overlapping, and then finding the probability of the combined event and write all answers as fractions. Find the probability of getting a black 4 or a red 7 on one draw of a standard deck of cards. So the key thing here is the word or. So when you see this word or, you know to look at your reference sheet for the or probabilities. And you have to figure out if you're going to have an overlapping or a non-overlapping event. Can a card be a 4 and a 7 at the same time? No. So this is non-overlapping. I cannot write with this pen today, huh? And the probability of getting a black 4 is 2 out of 52. And the probability of getting a red 7 is 2 out of 52. So we're adding those two probabilities together, and that's going to add to give me 1/13. Let's see if I can write this a little bit better on my second time down here. Finding the probability of rolling a 3 or a 5 on an unfair roll of a die. Now, we've done this problem before, but we just did it in a little bit different way of finding our answers. We looked at just favorable outcomes divided by total outcomes. Here, if we're going to look at it as an or probability, compound probability, then what I want to do is first of all figure out if it's overlapping or non-overlapping, and it's non-overlapping because overlapping, because when you roll a die or a number cube, you cannot get a 3 and a 5 at the same time. Probability of getting a 3, 1 out of 6. Then we're going to add to that the probability of getting a 5, which is 1 out of 6. and that is going to multiply or add together, I should say, to give me 1/3. Find the probability of picking either a red card or a king from a deck of cards. Figure out, do we have overlapping or non-overlapping? And here we have an overlapping probability because a card can be red and king at the same time. Let's see if I can actually write this out this time. That's better. All right. So what I want to do is figure out the probability of getting a red card and add to that the probability of getting a king. And then I'm going to subtract off the probability of both of those going on at the same time. So I'm going to subtract off the probability of getting a red king. And remember, you can use your reference sheet for this to show you what all the cards look like. Probability of getting a red card is 26 out of 52. Probability of getting a king is 4 out of 52. And the probability of getting a red king is 2 out of 52. And you stick all that in the calculator and you get 7/13. Problem 4, getting a sum of 4, 8, or 10 on a roll of a dice, a roll of 2 dice. This goes back to the handout that we did in class, so you need to get that chart out and look at that, and that will help you get this answer. And there's a couple of ways to do these problems, but if we're doing the problem the way that we've done the first 3 here, then the first thing we're going to do is figure out if it's overlapping or non-overlapping. So you have a number that's a 4, 8, and a 10. No, number can't be a 4 and an 8. It's either a 4 or an 8 or a 10. So these are non-overlapping. Okay. The probability of getting a 4, if you notice on your chart there are 36 outcomes on your chart, and there's 3 of them that are a 4. There are 5 of the sums that are 8, so the probability there is 5 out of 36. And there are 3 ways that you can get a 10. So the probability there is 3 out of 36. And all of that is going to add to give you 11 out of 36. Getting a multiple of 2 or a multiple of 3 on 2 rolls of the dice when you add the numbers on the dice. Again, we are looking at an OR probability, and we have to figure out, is our probability overlapping or non-overlapping? In other words, can a number be a multiple of 2 and a multiple of 3 at the same time? Well, yes. So this is an example of overlapping probabilities. And here I'm going to draw a circle and write all of the multiples of 2. And here I'm going to draw a circle and write all the multiples of 3, and then we're going to see if there's numbers in here for the overlap. Okay, multiples of 2 would be 2, 4, 6. I'm going to put 6 in here because 6 is a multiple of 2 and it's a multiple of 3. 2, 4, 6, 8, 10, and 12 is also a multiple of 3. And 12 is as high as we go on the sum charts when we're rolling 2 dice. Multiples of 3, 3, 6, 9, and 12. So I need to find the probability of getting one of these numbers, which are multiples of 2, the probability of getting one of these numbers, which are multiples of 3, and then subtract off this overlap right in here, which are the numbers that are multiples of 2 and 3. So if you look at your chart and count up how many of those numbers are on that chart, there's 18 of them. So the probability that your number is a multiple of 2 is 18 out of 36. The probability that your number is a multiple of 3 is 12 out of 36. And again, we're looking at that chart that we did in class. And then we're going to subtract off the overlap. So subtract off how many 6 and 12s there are, the probability of getting a 6 and a 12. And there are 6 of those numbers in there. So subtract off 6 out of 36. And that will give you 24 out of 36, which simplifies to 2/3. Okay, the next problem is a spinner. I'm doing something a little bit different here other than just cards. Probability of getting a 3 or a 5. Now, this is an example of a non-overlapping probability. The probability of getting a 3 is 1 out of 8. So there's 8 section here. The probability of getting a 5 is 1 out of 8. And when we add that together, we get 2 out of 8, which simplifies to 1/4. Now, we could have done this problem like we did it in the first section, and there's 8 different outcomes. 2 of them are favorable, so 2 out of 8, and that simplifies to 1/4. Problem 7. Probability of getting a number less than 6 or a shaded number. Okay, so again, the or going on here says that I have to add probabilities. So the probability that the number is less than 6. Okay, there's 8 different sections here. Numbers that are less than 6 would be 1, 2, 3, 4, 5. So the probability that it's less than 6 is 5 out of 8. The probability that it is shaded is 4 out of 8. And then we have to subtract off the overlap. So we have to subtract off the numbers that are less than 6 and shaded, which would be this one, and this one. So we have to subtract off 3 out of 8. And that is going to give you 3/4. Problem number 8, find the probability of picking either a diamond or a 7 from a deck of cards. So can a card be a diamond and a 7 at the same time? So yes. So that is overlapping. Did I say that this other one up here was overlapping? I didn't. So let's go ahead and write that in real quick. This one is overlapping. And this one is overlapping as well. So I want the probability of getting a diamond, and then also the probability of getting a 7. I'm going to add those together and then subtract off the overlap. Let me write this out here. The probability that I'm going to have a diamond, add to that the probability of getting a 7, and then subtract off the probability of getting a 7 of diamonds. Probability that you're going to get a diamond, 13 out of 52. Probability that you're going to get a 7, 4 out of 52. And subtract off a 7 of diamonds. Well, there's only one of those, so subtract off 1 out of 52. And that is going to end up being 4/13. Problem number 9, what is the probability to draw a jack or a number more than 4? So again, we're looking at our or probabilities. You look at your reference sheet, and it will tell you that you've got 2 different options, either overlapping or non-overlapping. In other words, can a card be a jack and a 5 at the same time? So, or a number more than 5 at the same time? And the answer is no. So these are non-overlapping. Okay. So the probability that I'm going to get a jack is 4 out of 52. I'm going to add to that I get a number more than 5. Now my numbers that are more than 5 are 6, 7, 8, 9, and 10. So I have 6, 7, 8, 9, and 10 hearts, 6, 7, 8, 9, 10 diamonds, and of clubs and of spades. So I've got each of those for each of the 4 suits. There's 1, 2, 3, 4, 5 of them for each of the 4 suits. So 5 times 4 is 20, and you can always just go back to your little reference sheet and count them all up if you don't want to do it this way. So there's 20 of these, so the probability that you're going to get one of those cards would be 20 out of 52. That's 24 out of 52, and that simplifies to 6/13. What is the probability that you draw a spade or an even card? So can a card be a spade and even at the same time? Yes. So it's overlapping. Okay. So we're going to find the probability of getting a spade. Add to that the probability that we're going to have an even card. And then subtract off the probability that we get an even card that is a spade. Well, there's 13 spades, so 13 out of 52 is the probability that I get a spade. Now, my even cards are 2, 4, 6, 8, and 10. And so I have that for diamonds. I have this for hearts, for clubs, and for spades. So I have 20 of those. So the probability that I get an even card is 20 out of 52. And then we need to subtract off the even spades, and there's 5 of them. So 5 out of 52, we're going to subtract, and that will end up giving me 7/13 for my answer.